This is a solar hot water system which has these mirrors and these solar water heaters. I remind you that I am looking for interesting combinations of mirrors and solar heaters, and these are some interesting mirror combinations which will be described in my future videos. So, the topic of this video is this mirror system, which had this design the year before last. One of my previous videos described this system of 6 solar heaters, which are connected by these hoses to this tank for 50 liters of hot water. Water circulation between the tank and the solar heaters takes place without a pump. This phenomenon is sometimes called the term gravitational circulation of water, and it takes place if the tank is located higher than our solar heaters. But now I have added the mirrors, and we see this part of reflected solar radiation from the mirrors. Let's look how much heat is produced by this hot water system, and now 27 liters of water of the tank have a temperature of almost 27 degrees Celsius. 5 hours later, we see that the sun has heated those 27 liters of water to a temperature of 51 degrees Celsius. This experiment is described here, where I indicated the heat production, thermal capacity of the water heating, and area of the solar heaters. We see that the average capacity was almost half a kilowatt per square meter of the heaters, despite large heat losses from the tank and the hoses. So, the addition of these mirrors allowed the use of only 2 solar heaters instead of the 6 that were the year before last. This became possible due to the fact that the mirrors increase the flux of solar radiation to the surface of the heaters almost 2 times, more exactly by about 80%. But for example, that percentage will be less for this case, because the angle of incidence of the rays from the mirrors is more acute. However, I must clarify that now this system works a little worse than the year before last, when it had these 6 heaters without the mirrors. I think that the system should have not 2 but 3 heaters with mirrors for it to work as well as this old system. Let's turn our attention to this part of solar radiation from the mirrors. This is the situation at noon, around the summer solstice, when the height of the sun above the horizon is the largest. We see that now the spot covers only 60% of the area of the solar heaters, but these percentages will be the greater the lower the height of the sun above the horizon. This is the situation at noon in late July, and here we see the edges of the spot, which already covers 90% of the heater surface. Therefore now the water heating capacity is noticeably greater than for the previous case around the summer solstice. We know that the spot will have exactly the same position in mid-May, because the height of the sun above the horizon will be the same. In addition, we understand that the spot will completely cover my heaters from August to April, due to the low height of the sun. However, morning and evening can create a similar situation, when the spot does not cover the entire surface of the heaters, and for example this edge of the spot corresponds to this edge of the mirror. It is obvious that the south must be there, and now I am showing the recommended tilt of the solar heaters and the mirrors for 50 degrees north latitude. Obviously, other geographical latitude requires different recommendations for the tilts and for this interval between my heaters. Interestingly, I recently improved the system, and now these mirrors are not flat but curves, and here we see focused solar radiation from the mirrors. Perhaps one of my future videos will describe various features of the new system with these curved mirrors.